Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, dear students. Welcome back to the TV Learning Series program. I'm Teacher Patrick, as usual, and I'm once again very privileged to be with you. And for the lesson of today, I will be with the Senior 6 class, which is chemistry, as usual. And we'll be looking at the nomenclature of aromatic amines. We look at the preparation methods of phenylamine, and then we look at the alkalinity of the phenylamine or aniline. By the end of this lesson, dear students, I hope you are ready with your notebooks and some pens to note down some very important information. So by the end of this lesson, we'd expect you to give the names of different compounds containing phenylamine. You'll be able to write equations to show the preparation methods of phenylamine. And lastly, you'll be able to explain the alkalinity of phenylamine compared to other aliphatic amines. So in the previous lesson, we looked at the chemical properties of the carboxylic acids, and we are looking at the acidity. You remember what we talked about, the acidity of these carboxylic acids. Aromatic, and we compared them with the aliphatic carboxylic acids. So this time around, let's continue and look at these amines and how these amines are named. So we'll just classify them as usual. These amines, whether aliphatic, whether aromatic, they are also classified as either primary, we have secondary, and then we have the tertiary. So when it comes to the aliphatic amines, you remember we have also the quaternary amines. So the quaternary, this time I will not talk about the quaternary, but we are talking about the aromatic. So we'll have to emphasize the compounds that have the aromatic ring. That is the benzene ring. So the aromatic amines or the allied amines, some of them, they may have substituted either directly on the benzene ring. Some of the examples, either if you have this is phenylamine, which is a simple aliphatic amine. So it is substituted directly on the benzene ring. Or we may have another one of this form. Either you have N with CH3, this is NH. So the methyl group is not attached, so you have this kind. So when you look at this one behaves as a primary amine, and this one will be a secondary amine. This is a secondary amine, and we may have even a tertiary amine, but having because what we are emphasizing on is the aromatic ring, not the other one. So you may have either N with CH3, or, so when you look at this one, there are three groups, the three alkyl groups, including the phenyl. So this one will be a tertiary, this is a tertiary amine. Remember, these are aromatic. Or we may have amines with other substituents. Amines with other substituents as well. So let us look at the structure and the nomenclature of these compounds, or some of these amines as we may look at. So let's take an example of those compounds. We have the first one over there. So I have to connect this one. So make sure that I point Exactly. So this is the compound I'm just talking about. This is phenylamine. The phenyl group, which is also sometimes called aniline. So here, this is a secondary amine. Secondary amines are not named as primary amines. They are not named as primary amines. As you remember, if you recall the naming of these amines, I will be discussing even the aliphatic amines later on. So the senior sixes praise, you'll be encouraged, you are actually asked to follow that video and see the naming of these aliphatic. So you'll be revising on that. So this is a secondary amine with N. So when we're naming the secondary, you remember, instead of naming the methyl, this methyl group, it is attached on nitrogen atom, not the carbon atom. So that's why you call it N-methyl. So that means the methyl group is attached on this nitrogen, and then phenylamine, because the whole of this one is a phenylamine, because the nitrogen is directly attached on this aromatic amine. So it is N-methyl phenylamine. So this methyl is a substituent in that case. So you may have other substituents. You may have other substituents. For example, you have the methyl group as an example. Take a look at this one. This is phenylamine, but it has another substituent. So that will be 4-methyl phenylamine. 4-methyl phenylamine. Or in case you have other substituents attached on the amine, on the benzene ring, containing the amine, so you have to consider, for example here, look at these two, the two compounds. These two compounds, this is an amine, but contains a carboxylic acid. This is an amine, but contains an OH, that is the phenol. So that means in naming, you need to consider the priority, order of these substituents. So in this case, if you have an amine and a carboxylic acid, because the carboxylic acid takes the higher priority compared to the amine. So the suffix, the carboxylic acid, because of its higher priority of the functional group, will take the suffix name. So this will be a benzoic acid, and therefore the amine becomes a substituent in that case. So that's why we say 2-amino benzoic acid. If I can just remind you of the priority order of these functional groups. So we have the carboxylic acids. We have a carboxylic acid. We have sulfonic acid. Sulfonic acid. We have the acid halides. We have from the acid halides, you may have the amides. You may have nitriles, the nitriles. You may have from nitriles, you may have aldehydes. Aldehydes, you have ketones. From ketones, you go to alcohols. And then as you move, the list is very long. So this is the decreasing priority. So when you have an alcohol and a the keton takes the priority, so it will take the suffix name. When you have a carboxylic acid, and for example, with an alcohol, the carboxylic takes the priority. For example, if I have a compound of this form, this is just reminding you of this. You have the OH, and then you have the carboxylic acid. There are two. So in this case, because of this order, this one will be, the compound will be a carboxylic acid, and this will be 2-hydroxy benzoic acid. So the this carboxylic acid taking the substituent. So that's what I'm just trying to mention here. 2-amino benzoic acid. 2-amino phenol. So the phenol, the alcohol, the amine is down in the on the priority list. So this is ethyl, this is, that is 4-amino ethyl benzoate. This is 4-amino ethyl benzoate. So that is some of the compounds that we can mention, and then naming some of those few compounds. So let's just proceed and move on to the preparation of the phenylamine. We are just looking specifically at the phenylamine. So the first one is the preparation from nitro compounds. In presence, these reagents, please take note. Whenever we are talking about these reactions, organic reactions, take note of the reagents that are used, the conditions that are used. Remember, these organic compounds are less reactive, and therefore those conditions must be present for them to, for the reaction to occur. Tin in presence of hydrochloric acid and sodium hydroxide, and then heat. These are conditions. The nitro group changes into the amine group. So that is one of the methods. This is a reduction method. Amines being prepared from nitro groups. So another method that we can look at is the chlorobenzene or the bromobenzene or the halogens attached directly on the benzene ring. When they are reacted with ammonia in presence of copper salt. So the salt of copper, either copper 2 sulfate, copper 2 chloride, copper 2 nitrate, or any other salt. Take note of the conditions, the temperatures and the pressure. Then the chlorine, here the chlorine, will be substituted with an amine group. So that is another important reaction. Then another one, it can also be reacted from, prepared from phenol, reacting with ammonia in presence of zinc 2 chloride. That is the condition, the temperatures must be around 300 degrees Celsius. That's at least a very high temperature. So the zinc chloride as a catalyst, temperatures of 300 degrees Celsius, phenol combines with ammonia to liberate aniline or phenylamine. Another method that we can talk about, this method, remember these methods that we are talking about also apply to the aliphatic amines as well. These methods also apply to the aliphatic amines. You remember the Hofmann degradation reaction, whereby the amides react with bromine. So this is an example of the amide. If you have, this is an amide reacting with bromine in presence of sodium hydroxide. That is in presence of sodium hydroxide. So it will change this one, reduce it to amine, that is CH3NH2 plus the sodium carbonate and plus the water and the sodium bromide. Sodium bromide. These are other products that are formed. But remember, for us, we are interested in this. So this is Hofmann degradation reaction. So it is also in aliphatic amines. So the aromatic amines also undergo the same reaction. This is benzamide. The benzamide in presence of bromine and sodium hydroxide, then it changes to this phenylamine. That is the main organic product. Some other products, for example here, you may decide to leave these other products. As long as you write the main product, then you have the reaction correct. So you have C6H, this is the amide, with the NH2 and reacting with bromine in presence of sodium hydroxide. And so this one will produce C6H5NH2, said plus sodium carbonate plus the sodium bromide and water. So these other substituents that are formed are not all that much important. The most important compound that is required is this that is being prepared. So so another method is the preparation from benzene, reacting it directly with the hydroxylamine. This is hydroxylamine. Some of the derivatives of the ammonia compounds in the presence of iron 3 chloride as a catalyst. Then that one also produces the phenylamine. So let's go to the alkalinity. The alkalinity or the basicity of the phenylamine. So the phenylamine, when you look at the structure of the phenylamine, this is the structure of the phenylamine. So I will try to put the bonds over there. This is the bond with the nitrogen. This is ammonia, or rather amine. And these are the bonds. All the bonds, I'll try to show all the bonds. So what happens, this amine group contains the lone pairs over here. So when we talk about the alkalinity or the basicity, we are referring the ability to remove the proton, the ability to attract the proton. That is the basicity. The acidity, so it is the opposite of the acidity. The ability to release the proton, that is acidity. Ability to attract the proton, that is basicity. So because of the presence of the lone pairs here, these lone pairs, because of the overlapping, they tend to move into the benzene ring. And then when that happens, then you'll have, because here, this carbon, when these electrons rearrange and form, so they will form a double bond. So this double bond, it means the bonds here are very many. So you'll have 1, 2, 3, 4 with another one, which is 5. Carbon cannot be surrounded by 5 bonds. So these electrons tend to move out of the ring. And as they move out of the ring, then they will form this compound over here. So you'll have, so this is now a double bond that has been formed. So when that double bond formed, there will be a positive charge. And this one now becomes a negative charge over here. There is a negative charge that is formed here. These are the electrons that have moved out of the ring. So these electrons don't remain out of the ring. Remember, there is a bond here and another bond here. So what happens, these electrons now tend to come back inside the ring. So when they come back inside the ring, what happens? That means if the bond is formed here, that means there will be also another problem. So these electrons also tend to move out. So this one will form. So here you'll have these electrons also moving out. And then they will form some negative charge over there. So you'll have another substituent that is formed. So the bond now forms here. Now we will have a negative charge forming over there. Remember, this one still has a positive charge. And there is this one over here. So that is what is happening, that negative charge. So as what happened here, these electrons will tend to move inside, again, once again, to stabilize the anion as these ones now move out. So these ones will move out of the ring. So eventually, what happens, you'll have, this is the double bond. So another double bond has been formed over there. There is a negative charge over there. And then you'll have the nitrogen with a positive charge. So remember, this is a double bond. So what happens, these electrons, as we have been showing there, these electrons will tend also to move in, as the electrons over here now neutralize they also tend to move out. So what am I trying to do here? So eventually, you will have your molecule in this form. So there is a bond there, there is another bond here, and there is a bond. So it is once again regenerated. So this one, when you look at this one, it resonates with this. You see the alternating of the double bonds. So because of the movement, why am I doing this? Because I had done this one earlier on. Why am I doing this? I want to show you that these electrons on the nitrogen, because I said from the beginning that the ability to attract the electrons, the ability to attract the proton will depend on the availability of the lone pairs. For example, if I represent this one, so in presence of the water, so one hydrogen here, so this one will form R with NH3 positive plus OH. So it has removed, there is one hydrogen that has been removed here. This one behaves as a base. I'm just assuming that this is the phenylamine. This is the benzene ring. Now, what happens is forming this. So the ability to remove the proton depends on the strength, on the variability of the lone pairs. The presence of the lone pairs. If there is something that can remove these lone pairs, that means reducing the lone pairs, it will reduce the alkalinity. If it increases the lone pair, increases the electron density on this, therefore the ability to attract the proton will also go high. So phenylamine is a very weak base. Why is it a very weak base? Because the electrons are not readily available. They enter into the ring. And once they enter into the ring, what happens? That positive charge. So that means the ability to remove the proton, their ability to remove the proton depends on the availability of the electrons. So that is, so if you remember for the aliphatic amines, the basicity also differ, and it differs depending on the substituents that are attached on the nitrogen atom. So in the gaseous phase, tertiary amines, I'm just talking about the aliphatic amines now. The tertiary amines are greater, or they have a higher basic character than the secondary amines. Which are greater with the primary amines, and these are also greater than ammonia. So I hope you could have also discussed this one also in details. However, in solution form, if it is in solution form, this is in gaseous phase. So in solution form, this order changes. So we'll have secondary, that is in solution form. So we'll have this. This is in gaseous form. This is the order of the basicity. So when we go to the in solution form, that is in water, if these amines are put in water, this is what happened. Secondary amines are greater than primary amines, which are greater than tertiary amines, and then greater than ammonia. So there is some change in the order. So I will not discuss this one in details, but what I just want to mention here is that this phenylamine is even a weaker base compared to the ammonia. So when you look at that, ammonia is the weakest. So phenylamine is much weaker. Why? Because of the delocalization of the electron, the localization of electrons, reduces the ability to attract the proton. That's why phenylamine is a weaker base compared to ammonia. However, the strength of the phenylamine will also depend on the substituents. For example, look at that. You have nitro, this is 4-nitrophenylamine. This is much weaker base compared to phenylamine. So why? This is dimethylphenylamine. So this one is weaker. So this one is stronger than this. So you have to compare this. Why is there a difference? The Kb shows the ability, the easiness with which the amine can dissolve in water to release the OH ions. pKb, this is the negative log of Kb. So don't mind about that. The higher the Kb, the lower the basicity of that compound. So you'll find that this one, the diethylamine, is a much stronger. No, this one, ethylamine, when you look at this one is stronger than all of this. So that means this, in terms of the Kb and K, so this one is smaller. This is bigger than this. So this one, that means this one is stronger than this one. Diethylamine is stronger than ethylamine, which is stronger than ammonia. Why are there so differences? Even with those ones that contains, and when you look at the methyl group with ammonia, so the effect of the substituents, you use the idea of the acidity, and then you can be able to describe the effect of substituents on the alkalinity of these compounds. So before I wind up, I just would like to leave you with some homework. So please make sure you capture that and then try to answer those questions. Outline how you would convert nitrobenzene into phenylamine, phenylchlorobenzene, 1,3-dinitrobenzene, 1,3-dichlorobenzene, N-benzoyl phenylamine, and so on. Then there is number 2. Capture that information. I hope you've already captured that. Thank you so much for being with me today. And thank you so much for being cooperative and participative in this lesson. Hope to see you in the next lesson. Bye-bye.